All right, it's going now. So on Friday, we didn't just talk about combining logs and different things like that. We talked about how to solve equations involving logarithms. So like this is something we talked about on Friday, how to solve 4 to the x equals 7. Do you guys remember how we solved it on Friday? We rewrote it? Into what form? Log form. This is clearly exponential form. We should rewrite it in log form. So, what is that? Log base 4 of 7 equals x, right? So that's how you rewrite it to log form. Do you guys remember how to actually type that in your calculator? Which one? You sure? Which one's on top? The 7 or the 4?
7.
You sure?
Yeah.
Like, kinda, but not really? Yeah, it is. Log base 10 of 7 divided by log base 10 of 4, or if your calculator can type the base in, just type base 4 and you're done. Do that real quick. 1.4036. I think on your test I'll ask for 3 decimal places, so let's just practice doing 3 decimal places. That's 1.404. So that's kind of the one way to solve this problem. Jason asked me on Friday, while you guys left, like, why is it log 7 divided by log 4? How do you know that that's what you're supposed to do to, like, figure out what that equals? And everybody else was like, just do what Mr. Thomas says. But there's a reason it turns out that way. And we're going to do that reason now. Because the rest of these things, equations that we're going to solve, we're going to do it the other way rather than this. This way is fine if it's like a really basic logarithm, like whatever. But like if you have like two, I can't even think now. When you have a bunch of stuff in the exponent and bases and things like that, it becomes a lot harder to rewrite. Okay? So we're going to use a different method to do this. So I have 4 to the x equals 7. That's what I'm trying to solve. So when you guys are solving equations, we're allowed to like divide both sides by 2. We can like square root both sides. We can add 3 to both sides or whatever like that. What we're also allowed to do is take the logarithm on both sides. And we're going to take the common log. We're going to take log base 10. So we can take the log on both sides. Because what does that let us do with this x in the exponent? No, I'm not going to rewrite it. Using the properties of logs, what can I change this exponent to? Yeah, in the front. I can move it to the front. I can make it a coefficient. So this becomes x times log of 4 equals log of 7. Then how would I solve for x? Divide, right? By log of 4. You see how, okay, that's still the log 7 divided by log 4. It's the same thing that we got earlier. Okay, so that's exactly why it is when you're evaluating log base 4 or 7, it's log 7 divided by log 4. So that's kind of like you showed how you came up with that. If you do it this way, you don't forget which one's on top and the bottom. We had to like, was it 7 on top, 4 on the bottom, and like you weren't sure. Doing it this way, like you don't have to remember. Like it just always works out correctly. You move log both sides, move any exponents to the front, and divide by whatever log you need to. So from now on, we're going to be doing it this way. Alright? So in part B, I have 3 to the 2x plus 1 equals 30. I may not want to rewrite it because that's a lot more messier to rewrite. So I'm solving this. I'm trying to get x by itself. What should we do first? Yeah, so we're going to put log in front of everything. So this is log base 10 of 3 to the 2x plus 1 equals log base 10 of 30. Okay, because I took the log on both sides, what does that allow me to do? What happened? Yeah. I can take the exponent and bring it to the front. Take whatever is in the exponent, move one on top, and bring it to the front. So now I'm trying to solve for x. I'm trying to get this eventually by itself. What do you guys want to do now? Divide both sides by log 3. On the left side, what happens? These just reduce to 1. So I still have 2x plus 1. Is this equal to 10? No. So we have to type that in and get a decimal. What was that? 3.09, and we can call it 6, right? Good paper. Good pen paper. Alright, how do I solve this now? Subtract 1, alright? And then what? Divide by 2. So I got 1.048. And that's all. So we're going to work on just solving like basic equations here. These are all exponential equations. All our variables are in exponents. Tomorrow we're going to talk about log equations, variables inside your log, and those get done differently. Okay. So I want you guys to do 2A and then B. You guys shouldn't have too much trouble with A. On B, you have a choice to divide by log 7 or divide by log 49. I suggest that you divide by log 7. You're probably going to need a calculator for all this. Apologize for not giving you enough room to do your work. You're on number 2. You should get a really nice normal answer. No, that's from part B, sorry.
Freaked me out. I was like, I didn't get an extra one.
So in part B again, if you have a choice and you're like stuck and you're deciding which log to divide by, I suggest that you divide by log 7 to get you normal, like non-decimal answer or like non-fraction answer. Right.
Wait, what?
Yeah. If you have a choice, take the smaller one and divide out. You still have a log 7. Jai, can you help me out with 2a? Yeah, so a lot of people do skip that step of writing the log first and then moving it out in front, but that's okay, as long as you don't mess up. So you have this, right? Okay, so what allows you to move that 2x to the front is having the log there, taking the log on both sides, right? Yep. So 1.6999, just like that. Mm-hmm. 50.
Yeah, there you go.
Thank you. Anybody get anywhere with B? Okay. So, what should we start off doing on B? Yeah, just write log on both sides. Melvin, what does that allow us to do with the exponents? Yeah, so these exponents get moved to the front. So 3 plus 3x plus 1 times the log of 49 equals 2x minus 6 times the log of 7. Get stuck there. You have a choice, right? Because there's x's on both sides. Like in the last one, there's no choice. You have to divide by log 6 because the x is on this side. Here, there's x's on both sides, so you have a choice. You can divide by log 49, or you divide by log 7. I told you guys to divide by log of 7. If you have a choice, divide by the smaller logarithm. Yeah, because what happens with this log 7 over log 7? They cancel out. Now I still have 2x minus 6. And over here, Jai, what did you get? When you did log of 49 divided by log of 7? 2. It's the same reason you just cancel these out. You're dividing this by that right now. Why should it be 2? Seems like a really strange thing that just turned out to be 2. Because like log of 30 divided by log of 3 wasn't 10. Why would this just be 2? Okay, say that again, Jai. So you're saying 7 squared is 49, right? Yeah, that's the reason. Remember, logs just count exponents. So number of exponents between 49 and 7 is 2. 7 squared is 49. So how do I solve the rest of that? What? Okay, or distribute. Yeah. But dividing's fine. Most people would choose to distribute, so I'm going to go that route. Subtract 2x. Yep. Minus 2. Divide by 4. Negative 2. So yeah. So the more complicated exponential equations you have, you don't really want to rewrite everything so much. You want to just start off by taking the log on both sides, and then like it'll just kind of keep going. You can try to see what you're supposed to do to solve for everything. Let's look at 3 and 4. How are those different? They have e. So in 3a, I have e to the x plus 1 equals 30. So nothing else is different. It's just have e, base e. So in the last couple of problems, we took the log, like the common log on both sides. Can you guys guess what we're going to do to both sides in this case? What happened? Yeah, we're actually going to take the natural log on both sides. It actually doesn't matter, Melvin, except it's nicer when you take natural log when there's an e, and you'll see why, and you'll see what happens in a second. So when there's a base e in your exponential equation, you probably want to use natural log instead. You can use regular common log, it just makes your problem more difficult. It'll still work out, but you'll see what happens when we do natural log. What about what can I do with the x plus 1? Move to the front, alright? Not yet. What's the natural log of e? Melvin, why does that equal 1? Because you said 1 right off the bat. Why does that equal 1? Yeah, remember, like, this is thinking e to what power is e? 1. It's just like common log of 10. 10 to what power is 10? That's 1. Log base 5 of 5. 5 to what power is 5? That's still 1. So this is just 1, right? Natural log e is just equal to 1. So this kind of just goes away. So I just have the x plus 1. That's why it's easier to use natural log when there's e as the base of your exponential like equation. I'm going to subtract 1 from both sides. Does that make it natural log 29? It's just natural log of 30, and whatever answer you get, subtract 1 from it. So natural log 30, and then whatever answer I get, subtract 1 from it. 2.401. Talking about b, because there's other things in there that we got to do first to take care of before we get to natural log it. So on b, a lot of people are just like, there's an e, let me natural log it. You don't get to do that yet. You don't get to log both sides until you have just a base and then an exponent. Okay. Yeah, you got to do everything else first. So Jackie says we should subtract 2.5. That's 17.5. Is there anything else we can do before we natural log both sides? What was that? Divide by 7. You're right. Yeah. Jackie, I'm not allowed to put the 2x in the front yet until I log both sides. That's what allows me to move things to the front. Now what can I do? What? Yeah, I gotta put the ln or natural log both sides, Jai. What happens with the ln and e? Cancel it out to just be 1, so I'm going to just write 2x equals natural log 2.5. Then divide whatever we get by 2. So natural log 2.5, close parentheses, divide by 2. Once you guys do 4, just kind of just like that. Don't start off natural logging everything until you have a base and an exponent. So you had a base e and then the exponent. That's when we decided to natural log. Jonathan, can you help me out in 4? Okay, what'd you get from that? Mm-hmm. That's 3.2. No, what? Okay. Yep. And the natural log 3.2 divided by 3. 0.38. I'm going to go with 8 because it says 77. I think on your test I'll ask you for 3 decimal places, so that's why I'm just sticking to that. Here I wasn't clear, so it doesn't matter. Yeah. It depends. Like on your test, Eric, I'll probably ask for 3 decimal places. So 1, 2, and then 3. You look at that number. If it's bigger, it's 5 or bigger. You make that one go up. If it's smaller than 5, you just keep it. So a lot of people ask me like about this chapter, Mr. Kong. Logs are just weird. Why do I need to learn them? What are they used for? And different things like that. And so in the next couple of things, probably they're used for word problems basically. We use them to help us figure out how long we should wait for something to happen, like to figure out times and rates of different things. Right? So an initial investment, I put in $200, and after 7 years, it's now worth $315.24 after compounding continuously. I need to find what rate it was growing at. So the logs is going to help us figure out what rate like things are growing, how fast things are growing. First off, before we start doing the problem, I'll write a list of all the formulas we talked about, and we can decide which one we should use. So there's one with a +1 and plus or minus. There's one with a dividing thing in it, and there's one with an E in it. When do we use this one? What happened? You sure? Alright, let's talk about the first one. First one's annual, right? And it just says annual. It's either, what about the plus and minus? What the heck was that about? Yeah, plus is for growth, and minus is for decay. And it just says annual. That's the first one. The second one is the least likely used one. This is the one the banks use. When does the bank give you interest? Like just at the end of the year?
No.
Yeah, this is for like, so this form is like for monthly, daily, quarterly, or whatever like that. Instead of annually, it's like monthly or whatever. In Jai, that leaves the last one as continuous. I can't spell continuous. So whenever you see the words continuous, you use P times E to the RT. So we're going to use that. P times E to the RT. Yeah. So as we're plugging stuff in, we should try to figure out what we have and don't have. Do we have our A? Do we know what we want at the end? What happened? We know what the amount at the end, right? What is that? 315.24. Okay, so A stands for the amount at the end. P stands for the amount at the beginning. What was that? 200. E is just that number stored in your calculator that we want to use for compounding continuously. Do we know what our R is? Nope, that's what we're trying to find. Do you know what our T is? 7. So we're trying to find the rate of growth after 7 years. That'll take me from 200 to 315. Okay, so all the examples 1 through 4 are trying to help us like basic equations to help us solve this one. What should I do first to solve this one? Divide by 200, all right? $315.24 divided by 200. That's 1.5762. Can I write 7R? Will anybody be confused with that? What happened? Whatever. How do I solve this? Yeah. Do we use log log or natural log? Yeah. It doesn't matter, but this one is better to do natural log. This is what happens with the natural log and the e. Cancel out. Yeah. And I get R is equal to 0.065. When they give us R in the problem, do they write it like that? What's it usually written as? Percent. Right. Rate as a percent. How would I change this to a percent? 6.5%. If this problem occurs on your tests, I don't care if you give it to me as a decimal or a percent. I prefer a percent, but I won't mark you off. You guys all right? Yeah. So that's why logs are useful, is to help us get it at an exponent that we're trying to solve for. Once you guys do 6, in 2003 there were 104.9 million people in Mexico. It increases 1.7% continuously. How long will it take for Mexico to double its population? Let's not get political and say never, because they're always leaving and stuff like that. Let's not do that.
Mr. Cole,
Just
stop
solve-
being racist. Stop being
Just solve it.
When you said Mexico,
You knew something was coming?
mm-hmm.
And it wasn't illegal immigrants?
Hush.
Hey, there's a trick in this problem. You should know your A. Like, you should plug something in for A. It shouldn't be written as just A. But I didn't specifically tell you. You should know what A is, even though I didn't tell you. There's a particular trick. It does. You have your R. What you're solving for, though, Melvin, is time. After how many years will Mexico double its population? So you're solving for time in this case. Your P is 1.4 or 104.9.
That's your E?
That's your P. That's your principal. That's what we started off with, right?
Okay.
2003. That's what we started off with. I want to know after how many years will it take to double the population?
Which is what you will end up with.
So figure out what your A should be from that sentence. Um, I'm gonna set this up for people who are stuck. Just a sec. What'd you guys get for A? Where'd you get the?
9.
Where'd you get 209.8?
It
Double the thing, because I asked you how long it takes to double the population, and that's the population doubled. You know what your rate is? Make sure you're using it as a decimal and not a percent, and then solve for 2. I'll give you a couple minutes to finish solving. You forgot to make it. Dang what?
right?
Ish? Yeah.
40.
Something like that.
Yeah.
Yeah. So Jackie, how'd you get your answer?
I know your parents.
Yeah.
I divide by 1.
Which should that be without actually even pressing it in calculator? Yeah. 2. Takes it to double, so divide, that's 2.
And not so long. The E cancels out.
E cancels out.
Then you got to divide it by 0. And you get T is equal to 40.7 years.
So after about 40, 41 years, Mexico should double its population if they keep increasing at 1.7%. We're just going to do 2 more on the back, and then that's all for today. This is years, right? T's for time. Time shouldn't be in percent.
The answer should be like in percent, not in decimal.
Oh, like this one? That's a decimal we used. We made it to a decimal. Like they gave us 1.7%. You never use the percent. You always convert it to a decimal. Is that what you're saying?
No, because you know how you said you did it in percent?
Oh, the last problem. Okay, the last one we solved for the rate. That is all. Rates are given as percents. R is always percents. T is years and days and stuff like that, not percents. Yeah? Okay. Do 7 and 8, and then we'll call it a day. So in 7, I have a $125,000 piece of machinery. It's depreciating at 8% every year. How long will it take to be $50,000? Because something's going to happen to it at $50,000. First off, depreciating, is that... So, first off, which formula should I be using?
A equals T parentheses 1 minus.
Why minus?
Because decay.
It's depreciating, it's decay. I'm going to lose out 8% every year. Let's start with that. What's my A? What do I want to end up at? 50,000.
There you go.
Because, I don't know, maybe I'll sell this off when it gets to be worth 50,000 or whatever like that. What do I start off with?
105,000.
Yep. 1,000. 1 minus...
What's the rate? 0.8?
Yeah, 0.08%. If you want to write 92, that's fine, like 0.92. And the T is your exponent.
Yeah. Oh,
They all work out the same. Yeah. What should we do first?
divide.
Right. We don't have a base and exponent yet. We got to divide. So that's 0.4.
0.4?
Yeah. This is 0.92, right? When you type that in. Okay, so these reduced, and I took 1 minus the 0.08 and got 0.92 to the exponent t. How do I solve this now?
Divide it.
Rewrite it? Or I can't divide it yet. Because this is 0.2 to the n. What's that? I need to take the log on both sides. Now, there's no e. Do I have to use natural log? I can use regular log log.
But it's easier.
Doesn't matter. I'm going to use natural log just because it actually doesn't matter which one you use. So if you just use natural log all the time, you don't have to stop and think about which one to use, since they both work all the time, right? Natural log will both work just like regular log log. Doing the natural log allows you to move that t to the front. Because there's no e, nothing actually cancels out, and we have to actually type this in. So how many years we got to wait? What's this really close to?
11.
That's 11. Let's just make it 11. 11 years. So, the last problem. We are working for a law firm. Our profits have been going up 6% every year. This year we made $152,400. We're gonna figure out how long, after how many years, we have to wait until we make $1 million every year. So figure that out. So logs are useful. That's the use for them. It's like it helps you figure out how long you have to wait for something as you're growing or decaying exponentially. Yes. So the rate is the only one where you have this.
Wow.
Long time?
I gotta make sure.
You had to make sure of 1 plus
Yeah.
0.06.
Stop judging your students.
It's called grading when you're a teacher.
Hold stop. Not like Mr. Holmes. Is that it, Mr. Holmes?
Stephen Tang, what'd you set up? Yeah. So what'd you do? Wait, hold on. You skipped a bunch of steps. Yeah, I need to divide this first.
Oh, yeah, you gotta do that.
6.562. And then you natural log both sides, right? You move the t to the front, and you end up taking this divided by natural log 1.06. 32.